Assalamu alaikum students. So continuing our lectures with dimension analysis, let's take some more quantities, more few quantities of which we are going to calculate what dimensions. You might have read about work. What work equals to? As already I told you, W the work equals to what? Force into displacement. So W equals to F into S. Let us now write for the dimensions of force. So once we are going to write dimensions of force, and we know that force is equal to mass into acceleration. Force is equal to what? Mass into acceleration into S. S is so for mass we are having dimension of m, that is power 1 or simply m. So you will place like this m. For A we are having m0 L1 t minus 2 acceleration. Lastly, we have calculated it out. And for S, we're having a dimension of what? M0 L1 T0 because distance simple length. I can here also place M1 L0 T0. So here is M1, here is M0, here is M0. So we're having M1. Bases are same, parts will be added. So here it's L1, here it's L1. It will be L2. Here it's t minus 1, here it's t0, here it's t0, it will be t minus 2. So this is the dimension of what? This is the dimension for work. So simply, once you have to calculate the dimension of any quantity, you should first know what that quantity equals to. If you are now having the dimension, for pressure, what is pressure? Pressure equals to force over area. Now force as usual, that is mass into acceleration here. So if I will write the combination dimension for force, that will be m1 l1 t minus 2. This is the dimension for force because force is mass into acceleration. On combining these two, it will be m1 l1 t minus 2 over area. What is the dimension of area? It is L2. So I can place it like this. It is m1 L, it's going to go upwards, then it's minus 2 and plus 1, it will be L minus 1, it will be T minus 2. This is the dimension for pressure. If you have to see dimension for power, power is equal to what? Work over time. Power is equal to work done in unit time. So work, what is the dimension of work? Yeah, we're having dimension of work as sir M1 L2 T minus 2. What is the dimension of time? That is simply T or T1. So the dimension of power is M1 L2 T minus 3. This is the dimension for power. So on and so forth, you can calculate so many dimensions of every quantity. If you will take now angle, angle. What is angle? Angle equals to what? Arc over radius. So arc is length, radius is length. It is length by length. It is m naught L1 T0 over m naught L1 T0. So we will get a dimension of m naught L naught T0. So arc is angle is having zero dimensions, mass zero dimension, length zero dimension, time. So angle is having no dimensions, no dimensions. For example, if you will take refractive index, refractive index, refractive index, that is known by mu r n. Mu equals to what? C over v, velocity of light in speed by velocity of light in the medium. So for speed of light, it is m0 l1 t minus 1, and in the denominator you will have also m0 l1 t minus 1. So it is having zero dimension, m naught l naught t naught. So now you have to, does the refractive index have any units? You have to here remember the quantities. Most of the quantities which are having no dimensions are having no units. But we will remember like this. If a quantity does not have units, definitely it does not have dimensions. as a refractive index have no units. You might have read in your 10th class, previous classes. Refractive index is having no units, so it is having no dimensions. But although angle is having no dimensions, but it's having unit. You are going to measure angle in degree or radian. So you will say like this: if a quantity does not have units, it definitely does not have dimensions. But if a quantity have units, it may have zero dimensions or it may not have. Angle is the only quantity which is having zero dimensions, no dimension, but it's having the units. Refractive index, in the maximum cases, all the quantities which are having what, zero dimensions or no dimensions, though does not have any kind of units. Now if we will take another one, gravitational constant, we know from F equals to G m m over r square. If we have to calculate the dimensions of this very G, so how we'll do it? It will be G equals to F r square by m. So for F force, we are having dimension what? M1, L1, T minus 2. So for R it will be L2, and in the denominator it is mass, it will be M2, L0, T0. On combining these very dimensions, it is M2, it will be M minus 1 because it will go upwards. It will be L1, L2, it will be L3, it will be T minus 2. So these are the dimensions of G, the gravitational constant. Be M minus 1 dimension mass, 3 dimensions length, and minus 2 dimensions time. This is how we are going to calculate the dimensions of different quantities. At your home, just take your reference, take your NCRT book. There are so many quantities. Just work out at your home and calculate the more and more dimensions, so you will get boosted up. This was one of the lectures that I will be given on the website today, and there will be another lecture that will be very soon. Till then, Allah Hafiz.